Hello, my name is Carlos Uriel and today I'm going to present the work entitled Addition of Geomaterials to Increase Mechanical Performance in Portland-Based Ceramics. Now, currently in Mexico, there are several geothermal fields in operation to generate electricity. In this research, silica from the Cerro Prieto and Los Azufres reservoirs was used. In accordance with the problem posed in the introduction, the partial substitution of silica as puzzolans in Portland cement-based mortars was used. Portland cement CPC 30RRS was used. The sand used came from the material bank called Joyitas, located on the Morelia-Jiquilpan Highway at kilometer 14.5 in Michoacán. While the silica came from two geothermal plants, Cerro Prieto, located in Baja California, and Los Azufres, located in Michoacán. For this research, it was decided to substitute silica obtained from the maintenance of the Los Azufres and Cerro Prieto geothermal fields because it has been shown to have cementitious properties. The percentage used as a cement substitution was 5%. The samples taken were cubes and cylinders, in which destructive and non-destructive tests, such as simple compression and electrical resistivity, were carried out. Okay, first, a control mix was prepared in which cubes and cylinders of mortar were made, with sand and cement already commented previously. Subsequently, a mixture was made with 5% silica substitution as a cement substitution, coming from the Cerro Prieto geothermal power plant. And finally, a mixture was made with 5% silica substitution as cement substitution, coming from the Los Azufres geothermal power plant. The test eggs were 14, 28, and 45 days. It is worth mentioning that the characterization of the materials as well as the development of the non-destructive tests and the destructive tests were carried out following ASTM and NMX Mexican standards. Next, we can see the non-destructive test called electrical resistivity, which is a property of each material and corresponds to the reciprocal of its conductivity. As we can see in the graph, the specimen with silica substitution of the azufres plant is the one that presents better results of electrical resistivity at different ages. Now, analyzing the compressive strength test, the test was performed on cubic specimens of 5 centimeters per side using hydraulic press at the different ages. The ages were 14, 28, 45, and 19 days. It is observed what the azufres plant mix at 14 days improves by 24% to the control mix, as well as Cerro Prieto improves in it by 8%. At 45 days, the azufres mixture outperforms the control same sample by 7%, while the Cerro Prieto mixture remains below the control sample. However, it is important to note that the trend of the azufres and Cerro Prieto mixes is upward. According to the ACI standard 211.3-75 and 28 days at with water semen radio, the compressive strength must be greater than 21 megapascals, which in the case of the three mixtures completes with the standard. Finally, as a conclusion, we can say that favorable results were obtained in the mechanical performance. So the substitution percentage used was adequate. However, it is worth mentioning that it is necessary to make substitution with different percentage to determine the optimum percentage. We can also say that the substitution based on cement by silica in the elaboration of mortars carried out for this research proved their effectiveness by being are replaced the decreases amount of cement in the mixture and provides superior mechanical performance than the conventional mortars based on Portland cement. Specifically, in the case of the azufre mixture with a 5% substitution.